Okay, welcome back, guys. Second video here talking about the preparation tasks for the upcoming SAC. Once again, we're looking at area under a curve. This time, a slightly different context. So we're looking at specifically designing a logo. So you can imagine how this might be turned into a more open-ended question than it is here, but this specific question has kind of all been given to you. So the electronics company is designing a logo based on the two graphs below. So we've got first up the graph of f of x is equal to 2 times sine x. I'm just going to illustrate that in orange. So that's that first curve there. And then we've also got the curve of g of x, which is this smaller curve here. So you can see the g of x curve has an amplitude that's equal to a half. It's got a period of pi. We can calculate the period by going 2 pi 2 pi divided by the coefficient of x here, which is 2, so you can see the period's equal to pi. And similarly, the period of the orange one is equal to 2 pi. So what we need to figure out is what is the area of the enclosed section there in the middle. So let's do this in green to start off with. So the area under the curve, which is all that stuff there, that there is going to be given by the integral from 0 to pi of this orange curve minus the blue curve. So subbing in the equations here, that is the equation of 2 sine x minus a half sine 2x dx. And we could just do that on the calculator. There are various geometric ways of interpreting this as well, of course. It is that area. So that would be the area from here to here. And you can see that the area from pi to 2 pi is symmetrical with that. It's the exact same thing. It's just reflected in the x-axis. So yeah, it'll be that times 2. So I'll just fit that up here. So 2 times that is going to give us the area under the curve. So let me just go ahead and type that into the calculator. We're going to find that the total area under the curve is equal to math2 to get up the integral sign. We're going to go from 0 up to pi. Make sure it's set to radians, always could be an issue. Of 2 times sine of x minus a half times sine of, 2x dx, and type that in. It tells us that the total area under the curve is equal to 8. And of course, we could do this by hand, practice your integral skills, but you don't need to do that for this particular test. You will for the exam, but for the SAC, it's tech active, so this is perfectly fine. No more level of detail than this is perfectly acceptable. So we can see that is equal to, in this question, the total shaded area in square meters can be calculated using this formula here. And we need to figure out what the value of A is here. So we can just go ahead and write up a sum for this. So the sum could be written like this. And we're effectively just solving for A here. So if we were to figure out what's the value of that second integral, so the bit that's written here in this question from 0 to pi of sine x, that integral, again, we could do this by hand, but it's going to be equal to sine x dx. That's just equal to 2. So we have here that 8 is equal to 2 times A, and therefore A is equal to 4. All right, so that's our starting question. Hopefully we all got that question. It says here 40% of people, when they did this exam, got this question correct. So this is an exam 2 question. Just 1 mark. You just need to write A equals 4. You don't even need any working out, really. So you can just do all that in the calculator. So going across the next question here, it says, okay, now the electronics company has decided to change the circular functions used in the design. Instead of using these ones, they're going to stick with y equals 2 sine x, so that's that orange curve, but they're going to change the blue one. They're going to instead use one with a slightly different period. So what is the period of this new function, this one that they're calling hx? Well, let's consider hx for a minute. The period of that function is going to be equal to 2 pi over the coefficient of x, which is 3, so 2 pi on 3, and we can see that the amplitude of this is equal to 1 over 3, so the thing that's at the front here. So we can now sketch that on the same curve over here. If the period is equal to 2 pi on 3, that means that over the course of this 2 pi, it's going to have 3 periods. So let's just count up. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 grooves here. So we want our first function to go for 12 divided by 3, which is 4 grooves. So we've got 1, 2, 3, 4. Okay, this is our first period, right? So this is a sine wave. So it's going to have an amplitude of a third. It's going to go up to here. It's going to go down to here. It's going to go up to here. It's going to go down to here. That's our first sine wave, okay? And we should, if we did this correctly, be able to fit 3 of these for this interval. So you can see, yeah, that seems to check out. And we can see that the amplitude across here, if we drew this a little bit more accurately, it'd be a bit clearer to see. But the amplitude's meant to be 1 over 3, and we can see that there's a total of 3 periods. So for the purpose of an actual exam, you should label each of the coordinates of these maxima and minima, just in case they care about that sort of thing. So for example, that first one over here is going to occur at x equals, what is this? So this was 2 pi over 12, so that's pi on 6. So pi on 6, and y equals a third, and then you can fill the rest in accordingly. Yeah, so that would be how you would label that. Given this one's only 2 marks, it would be a bit excessive to label all of them, but so long as the details here were generally correct, you ruled the line, maybe label a couple of them. You could probably label where the 2 lines intersect, so they're going to intersect over here at the points pi 0. But yeah, we should be able to label, yeah, like for best practice, just label all of the maxima and minima and intercepts here, which will take a bit of time, but that's how we do it. Okay, next, state a sequence of 2 transformations that maps the graph of y equals fx to the graph of y equals hx. So generally when we're listing transformations, we should list them in the order DRT. So in other words, dilations, then reflections, then translations. In this case, we've actually just got 2 dilations taking place. One of them's with respect to the x-axis, one of them is respect to the y-axis. So first up, let's consider what's happening to the y values. So I'm just going to simplify this a little bit. Let's consider that original graph, this one here, and let's see what happens to the y values. So what's happening is the maxima is going from y equals 2 down to y equals a third. So it's changing to here, right there, like so. So we need to change the values like so. We're going to start out with y equals 2, and that is changing to y equals a third. So what do we need to do to go from 2 to a third? Well, we need to divide by 3. Divide by 6, right? Or which is the same as multiply by 1 over 6. So what are we doing? Well, we're dilating this graph by a factor of a sixth in the direction of the y-axis or away from the x-axis. So let's put that into words over here. So this is dilation by factor of 1 over 6 in the direction of the x-axis. Away from the x-axis, I should say. Away from x-axis, okay? So that's that first one there. All right, so the other dilation is if we consider, let's use a different color, maybe red this time. Let's consider what's happening to the x values. So the total period is changing from 2 pi down to, so this overall 2 pi period graph, it's changing down to having a period of 2 pi on 3. So it is now going to look something like this, right? So it's going to change. I'm just sort of drawing that original graph where we're just considering the dilation with in the x direction. So that is a dilation by factor of what? Away from the y-axis. Well, what's happening is x is going from being equal to 2 pi to the new x value being equal to 2 pi on 3. And what do we do to get from 2 pi to 2 pi on 3? Well, we multiply it by 1/3. So the dilation is by a factor of 1/3 from the y-axis. And that is the transformations that are occurring here. So that's a sequence of transformations. So first, the graph of y equals fx is dilated by a factor of 1 on 6 from the x-axis. Second, it undergoes a dilation by a factor of 1 on 3 from the y-axis. Fantastic. Okay, moving on. Now, we now need to consider the generalized case of this predicament. So now the electronics company considers the graphs of kx is equal to m sine x. Okay, so let's now first just consider this. Kx equals m sine x. Well, that is a sine wave with a period of 2 pi. Let's draw this nice and big down here. So this has 2 pi period. It's a sine wave. So it's going to look something like this, right? Where the maxima and minima, I know it's not perfect, so I'm just using a stylus here, but this is 2 pi here. The maxima is the value of m, and the minima is a value of negative m. So that's what we're oscillating between here. So we're told that m is greater than or equal to 2, and also we now have to consider the graph of qx, which looks like this one here. So qx, we can see it's equal to 1 over n times sine nx. So the period of qx, the period is equal to 2 pi on n. So 2 pi over n. So it's this graph here, it's been divided into such that there is going to be n periods in total between 0 and 2 pi. So over this interval, there'll be n periods. And also the amplitude is much lower. So in other words, we're going to have something that looks something like this. Okay. And that graph of qx is going to have a maxima that will be 1 over n. So in other words, it's got an amplitude of 1 over n, and its minima is negative 1 over n. And of course, we know that this is going to be an even number of periods. Okay, so that's our context here. And the question is asking us, find the area enclosed by the two graphs over this interval. So let's illustrate that using orange here. So we're looking for what is this area here enclosed by the two graphs, right? And we've got this integral here as well. Now we're also told that both m and n are integers, and specifically n is actually an even number in first part here, I. Okay, so let's write this out. So first up, how do we compute this area? Well, this area is equal to, let's have a think about it. So just like in the first question here, that first part of the area from 0 to pi is exactly the same as the area from pi to 2 pi. It's the same graph. It's just been reflected in the x-axis. So we could find this area as being equal to 2 times 0 to pi of this top graph here, which was kx, minus qx dx. So that's what we're computing here. So that we could write as 2 times 0 to pi of kx, which was, of course, just scroll up a little bit, which was m sine x, and qx is 1 on n sine nx dx. Okay, that's what we're finding first up. So let's expand this out before we do any further simplification. So first up, what is the antiderivative of this? So we've got the 2 at the front. First up, the integral of sine x is negative cosine x. So this first antiderivative is just going to be negative m cosine x. And then the second one here, so this one here, to find the integral of that, we need to go so overall this will be negative cosine of this, and then we need to divide by the thing inside the coefficient of x inside of the sine here. So that's n. So therefore, the antiderivative of this will be 1 over n squared cosine nx. And notice there, of course, that due to taking out the negative, we've also got another negative there. So we have a double negative, which leads to a positive over here. And that's from 0 to pi. All right, fantastic. So let's now find what the area is equal to. So we're just going to sub in these values. So first sub in pi, then sub in 0. So overall, this area becomes negative m cosine pi plus 1 on 1 on n squared cosine pi n. So that's the first bit of this integral, minus negative m cosine 0 plus 1 on n squared cosine 0. Okay, that's what we're finding. All right, so first up, let us consider part I. So it says here, n is even, right? So n is even. So this is really just testing our ability to understand trigonometric ratios. Of course, we could just do most of this on the calculator, but let's have a think about it real quick. So this is a unit circle, right? If we first think about this value here, cos pi, what is that equal to? Well, cos pi, that is half a rotation around the unit circle. That puts us right here. And cos is, of course, the x-coordinate of a point moving around the unit circle. So that is an x-coordinate of -1, isn't it? So that is going to be equal to -1, that cos pi bit there. Now let's consider cos pi n. Well, we know that n is an even number, right? So if we think about going around a unit circle, we're at pi here. This is 2 pi. That's 4 pi. That's 6 pi. If n is an even number, then cos of n pi will always position us right here, which is at the point 1. So this value here, cos n pi, is just equal to 1, provided that n is even. If we know that n is even, then that thing's just equal to 1. And then this last part over here, well, cos 0, that's just equal to 1 as well. And then cos 0 is also equal to 1. So that gives us most of what we need. So let's just fill in the rest of it. This is equal to 2 times negative m times -1 plus 1n squared times 1 minus, and then we've got negative m times 1 plus 1 over n squared times 1. All right, now let's have a look at this overall expression. What can we cancel out here? Well, we might see that we have 1 on n squared times 1 minus 1 on n squared times 1. So that's just 1 on n squared minus 1 on n squared. They cancel out. Easy, dealt with that. Next up, we can see over here we have negative times negative. So that's just 2 times m minus negative m times 1, which is just m. So we have 2 times m plus m, which is equal to 2 times 2m, which is 4m if n is even. Okay, so that's part I. And that is giving our answer in the form am plus b over n squared, where in this case a is equal to 4 and b is equal to 0. So let me just, maybe we'll put the answer in the form that they want it to be. So that's 4m plus 0 over n squared. So just putting it in the form of the question. Now, let us consider the alternative answer, which is part II. And part II says, find the area now if m, in terms of m and n, if n is odd. So now let's consider the case where n is odd. So we'll jump back to this expression here. So everything else about this question should be the exact same. The area is going to be equal to 2 times negative m cosine of pi plus 1 on n squared times cosine pi n minus negative m times cosine 0 plus 1 on n squared times cosine 0. Okay, I realize that's a bit messy, but it's just the exact same thing as what's written in this line right here. Right? So in this specific scenario now, what's going to happen? Well, if n is odd, then where are we around this unit circle? Well, if we go around an odd number of pi's, pi rotations, so cos pi is equal to -1, cos of 3 pi puts us here, which is also -1, cos of 5 pi is -1, so cos of n pi, where n is an odd number, will be equal to -1, right? So what does that mean? Well, that means that this expression over here, which is just this line here copied down, is going to become, okay, first up, cos pi is still just equal to -1. That doesn't change. Then we have 1 on n squared times this thing here, cos pi n, which is now equal to -1, minus negative m cosine 0, that's still equal to 1, and we have 1 over n squared times cosine 0, which is still also equal to 1. So how does this simplify down now? Well, now we now have two negatives. So if we expand this out a little bit here, we can see, I'll just do it over here first, just because I'm aware that we're running out of space here. That's going to be equal to 2 times m, so negative m times -1 is equal to m, minus 1 over n squared, and then we have negative m, so that becomes plus m, and then negative 1 over n squared, so that's negative 1 over n squared, like so. And we can collect that together. This is just going to be equal to 2 times 2m minus 2 over n squared, which when we expand the brackets is equal to 4m minus 4 over n squared, where n is odd, right? So that's how we answer this question in the general case. And how does that compare? Because there might be a question like, how does this, or like illustrate this with an example, or how does this compare with your results from earlier? So we might notice that this answer in green, this one here, that's sort of similar to part A, wasn't it? So in part A, we had n was equal to 1 over n was equal to 2, right? So 2 is an even number, so that's 1 over 2 sine 2x. And yeah, we had that a was equal to 4m. In this case, m was just equal to 1, right? In our general case. So yes, that lines up with our result from there. We had an answer that gave us an area of, a total area of 4 times 2. So yeah, in this case, m was this value here. So that's like the m value here, m equals 2. So the area here was equal to 8, which is 4 times 2 in this formula down here. So yes, the area was equal to 4 times the m value in that specific case. And what about II? Well, II should give us an answer that looks like this, right? So in this other part here, we didn't actually have to find the area in part B, but if we did, it should follow this pattern here as well. So the area of that question there, so the area for part B, which was this area, so between that larger one and that purple one between here and here, hypothetically, that should be equal to, so 4 times m, so in this case, m was equal to 2, minus 4 over n squared, and n is equal to 3 in this case here. So if we wanted to illustrate this with the example, it should be, 4 over 3 squared. 4 over 3 squared. So hypothetically, the area for this question here should be equal to 4 times 2 over 4 times 3 squared, so 68 over 9 should be the integral for this question, part B. Although it didn't ask us to find the integral, but I would encourage you to set up the integral to find the orange area here. The way you'd need to do that is to go the integral from 0 to pi of that one up the top, so 2 times this, that one up the top, minus the one down the bottom. Does that give you an answer of 68 over 9, in which case you can illustrate this generalized case that we found in the last couple of questions here. All right, so that's how we answer these questions. Hopefully this little video assisted you somewhat. And yeah, I will see you guys soon. Have a good one. Thanks.